Hello students, welcome to JSM Learn. So in this today's video, we are going to learn some of the previous IIT JEE Main questions and their solutions from the chapter Structure of Atom. So from the selected concepts of Bohr's model of hydrogen atom. So let us see the first question what they have given here. So the question they are saying here as the energy required by electrons present in the first Bohr orbit of hydrogen atom to be excited to second Bohr orbit is in joule per mole they are asking, and they given the RH value as 2.18 multiplied by 10 to the power of minus 18 in ergs. So note this point, units are important. So why? Because they are asking in joule per mole and the given information is in ergs. So now let us see the given data. So RH value is given, and we know the formula energy is minus RH multiplied by Z square by N square, where Z is atomic number. So here the hydrogen atom they have provided us. So hydrogen atom, so where Z value is 1, Z value is 1. So next, for the given transition, N1 is equals to 1, N2 is equals to 2. So as they are saying present in the first Bohr orbit and it is excited to second Bohr orbit. So N1 value, N2 value also they have provided. Now change in energy or energy value we can write as what? 2.18 multiplied by 10 to the power of minus 18 multiplied by Z square. So as this value is in what? They have provided as in ergs. So converted into joules, and this one for joule per atom value. Joule per atom. So on substituting the values, so delta E can be written as what? 2.18 multiplied by 10 to the power of minus 18. Z value as it is hydrogen atom 1. So on multiplying 1 square only, 1 upon N1 value is 1 whole square minus 1 by N2 value is 2 square. So on simple calculation we are going to get this value as delta E is equals to 2.18 multiplied by 10 to the power of minus 18. Here 1 upon 1 minus 1 by 4 you will get. On taking LCM will get this value as 3 upon 4. On simplification, this value will get as delta E is equals to 1.635 multiplied by 10 to the power of minus 18. This is for joules per atom, per single atom. So we have to convert it into joule per mole. As we know, 1 mole of any substance will consist what? Avogadro number of particles, Avogadro number of atoms. So that is what we have to multiply this value. 1.635 multiplied by 10 to the power of minus 18 has to be multiplied by Avogadro number to convert for joule per mole. So that is what Avogadro number 6.022 multiplied by 10 to the power of 23 atoms per mole. So we will get joule per mole. On multiplication of this value, you will get the energy value as 9.835 multiplied by 10 to the power of 5 joule per mole. So 9.835 multiplied by 10 power 5. So the option we have here as option A. Okay. So like this you can solve. So let us go for the next question. Here they have given some information as which of the following statement regarding the energy of the stationary state is true in the following one electron system. So according to Bohr's atomic model we have to solve this again. So now which is the true statement? So they have given, so option A. So energy for second orbit of hydrogen atom. So energy for for second orbit of helium plus. So option C they have given this much energy for first orbit of helium plus again. So option D they have given for what? Energy for third orbit of lithium plus 2. So now as you know the energy formula, minus 2.18 multiplied by 10 power minus 18 Z square upon N square joule per atom. So now you can see the options here. Firstly, eliminating process we call it as usually. So as this is sign, energy sign itself it is consisting minus sign. So where in the option B and option C which are consisting plus sign. So we can eliminate these two options. Now let us see how to solve this. So z square upon n square. I am starting from this first option. So here second orbit means n value is 2, and z value is 1. So on substituting this value, what we will get? Energy, on checking for option A, energy is equals to minus 2.18 multiplied by 10 to the power of minus 18. So z square, here the value of z is what? For a first option, so we have seen z value is 1 square, n value is 2, so 2 square. So that means we will get this value as 1 upon 4. So minus 2.18 multiplied by 10 to the power of minus 18 upon 4 value. So you can check the option here. This one is the half of 2.18 value, but 4 times means you will get half of 1.09 value. So that means this option is also wrong, we can easily say. So whether we are going to get the option D also not, let us check now. So energy formula is what? Energy is equals to minus 2.18 multiplied by 10 to the power of minus 18 into z square by n square in joule per atom only, joule per atom. So now look at the option, minus 2.18 multiplied by 10 to the power of minus 18, z value for lithium is 3 square upon n square. N is what? Third orbit they are saying here, so 3 square. So in this case we are going to get the value as minus 2.18 into 10 to the power of minus 18 joule per atom. Energy value we got here. So now which is matching with the option D. So like this easily you can select the correct options. So now here a practice question for you students. So what is the energy in joule per atom required for the following process? So following process means they are removing an electron, okay, Li plus 2. So removing means ionization energy, okay, yes, they have given here the ionization energy of hydrogen atom in ground state, 2.18 multiplied by 10 power minus 18 atom. So in the third question they are mentioning the information as the hydrogen spectrum consists of several spectral lines of Lyman series. So hydrogen spectrum Lyman series they are saying L1, L2, L3, and L1 has lowest energy. So L1 has lowest energy in Lyman series means, as we know that in Lyman series lowest energy will be possessed by the first line, N1 is equals to 1 and N2 is equals to 2. First line will have lowest energy. Next similarly it consists of several spectral lines in Balmer series. So B1, B2, B3, and in that B1 has lowest energy. So B1 has lowest energy. In Balmer series lowest energy will be consisted by again first line, N1 will be 2 and N2 will be from 3. The energy of L1 is x times to the energy of B1. The value of x is they are asking. So now energy, we know the formula, we can write this one also, energy is equals to 13.6 multiplied by z square into 1 upon n1 square minus 1 upon n2 square, or we can use the formula energy is equals to 2.18 multiplied by 10 to the power of minus 18 z square into 1 upon n1 square minus 1 upon n2 square. This one is joule per atom, this one is electron volt per atom. So now we are using this formula. So firstly I am trying for the Lyman first line, okay. So here they have given the values as N1 value is 1, N2 value is 2. 2.18 multiplied by 10 to the power of minus 18. So for the which atom they are saying? Hydrogen atom, okay. So hydrogen atom they have mentioned. So Z value will be 1 in both the cases. So here 1 upon N1 square, N1 is 1 whole square minus of N2 is 2 whole square. So from this we will get the information delta E of L1 line is equals to 2.18 multiplied by 10 to the power of minus 18. On simplification of this we will get the value as what? So 3 upon 4. So same way we can check for the Balmer series. According to the given information, energy of Balmer line B1 can be calculated as what? 2.18 multiplied by 10 to the power of minus 18. Again this line is also for hydrogen. So as we can take it as what? 1, Z value as 1. So 1 upon N1 value is 2. So 2 square minus 4, just a second. So 2 square minus of 1 upon N2 value is 3. So 3 square. So on calculating this value, we will get as what? Delta E, energy value as of B1 is equals to 2.18 multiplied by 10 to the power of minus 18, 1 upon 4 minus of 1 upon 9. So on simplification, we will get as 5 by 4 into 9. So now the ratio I am taking this one of energy of L1 line and energy of B1. So energy of Lyman series first line, energy of Balmer series first line. So that could be written as what? Here both the values I am writing here 2.18 multiplied by 10 to the power of minus 18, which is 3 upon 4 here, 3 upon 4 divided by 2.18 multiplied by 10 to the power of minus 18 multiplied by 5 upon 4 multiplied by 9. So on simplification, we will get the value as 3 divided by 5, where 9 goes here, 9 3s are 27 by 5. On simplify as what? 5.4. Okay. So now this can be written as what? 54 multiplied by 10 power minus 1. So here they have given as 10 to the power of minus 1 in the question itself. So our answer x value is 54. So like this we can solve the question number 3. Now let us go for the next question. What they have provided here, the species having identical radii according to the Bohr's theory. Identical radii means which are having the same radius. So as we know, the radius formula is 0.529 multiplied by n square upon z angstroms. So here we have to identify the value of n square by z. So as per the provided data, so hydrogen atom, that means let us write the values n orbit number and z value I am writing. So for in the case of first one, hydrogen atom and first orbit means 1, first orbit, in the second case also 1, second orbit, next first orbit, so second orbit. So orbit numbers I have written. Next atoms, their atomic numbers, hydrogen, helium, okay, again helium plus, next lithium, beryllium they have provided. So now n square by, so here I am solving for n square upon z value. So n square upon z value here will get as 1, n square upon z value, here it comes 1 by 2, that means 0.5 value. So in the first case we got as 1, so second 0.5, third case 2 square by 2, that means 4 upon 2, you will get the value as 2. Here 1 square by 3, 1 upon 3 will get as 0.3. Okay. So now here in the next case 2 square upon 4 means 4 by 4 will get the value is here as 1. So in the first case and in the fourth case we got radius value is 1, radius is going to be 1 and fifth case. So the option B is the correct answer for this question. Information, the Bohr radius of hydrogen like species, okay, radius of hydrogen like species they have provided as 70.53 picometer, and the species and the stationary state they are asking us. We have to identify which ion it is and its state also we have to identify. Given hydrogen Bohr radius as 52.9 picometer. So the given data is here. As we know the formula, radius is equals to a naught multiplied by n square upon z. So we have to identify n and z value according to the given question. So Rn 70.53 picometer is equals to 52.9 picometer multiplied by n square upon z. So here n square by z can be written as what? 70.53 picometer divided by 52.9. On solving this value, we will get as 1.33. So that means n square upon z, which we got as 1.33, can be written as 4 by 3. So 4 by 3 also we can get the value as 1.33. So from this, n square upon z can be written as 2 square upon 3. So N value we can write as 2 and Z value is 3. So, as atomic number is 3 means here we can take the ion as lithium plus 2 and the stationary state is second one. So, Li plus 2 and second. So, in this option D directly we can select. So, thank you. Follow our channel for more solutions like this. Thank you.